Hi, welcome to 11.7, more about parabolas and their applications. Hopefully by the end of this, you all will be able to graph and find the vertex of a quadratic function in standard form. And hopefully you'll also be able to solve application problems involving maximums and minimums. So, we're just going to start out with an example of a quadratic in standard form. So in example 1, I've got f of x equals x squared plus 4x minus 9. You'll notice that's in standard form. It's all multiplied out. The exponents go from highest to lowest. It's not in that vertex form. And reminding you from last time, the vertex form, what it looked like was f of x equals a times x minus h squared plus k. That format was really nice to find the vertex. There's the x-coordinate of the vertex, there's the y-coordinate of the vertex. And we're not there yet, okay? So that's actually what we're going to do first, is we're going to try to get this standard form into that vertex form. And how we're going to do that is by completing the square. So if you remember from completing the square, you've got your x squared, you've got your middle term, and we're just going to do a plus blank because I need to complete the square. I'd rather keep my minus 9 on this side of the equation than to move it and then move it back, because you notice that plus k, it's on that right side. So I want to keep all my numbers here. We'll just combine like terms in a minute, okay? So let's go ahead and complete the square. So a little refresher from completing the square with perfect square trinomials. This b value, it should be the square root of a times the square root of b times 2 is that middle value. So the x comes from the x squared, so the 4 is basically going to be 2 times our b value. So if I do 4 divided by 2, you get 2, and then I'm going to do 2 squared to complete the square, okay? Now you'll notice that I just added basically 4 to that right side of the equation, and that just makes it 4 bigger than it was, so it's not the same value anymore, so I need to balance that out. So your choices are either you could add 4 to the other side, to the left side, or we could subtract 4 from this side. Again, I would rather do everything on the right side because my k value is over here. If you add 4 to the left side, you'll just subtract it from both sides, and we end up in the same place. It's just an extra step, okay? So adding 4 and subtracting 4, those balance each other out. So that's why I'm subtracting 4 here. It's just to balance. Alrighty, now that we completed the square, we have a perfect square trinomial. It factors nicely. That's x plus 2 squared, okay? And then I can combine like terms over here. Negative 9 minus 4 is negative 13. So now we're in that vertex form, which means I can find my vertex, my x-coordinate. You notice that this is a minus h, not a plus h. So plus 2 is the same thing as minus and negative 2. So the x-coordinate for my vertex is actually negative 2, not positive 2. My y-coordinate, the k value, is exactly what it is over here. So it's a negative 13. My y value is a negative 13. And now we have the vertex, okay? And so that's how you can find it, by completing the square. All right, little shortcut for you is the vertex formula. So the graph of that quadratic function, and we're going to define it. We have that a value, b value, and c value, just like when we were doing the quadratic formula, okay? A, b, and c are the same a, b, and c as before. It has the vertex. Basically, your x value is the opposite of b over 2a. And so, kind of going back to that quadratic formula, remember x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Do you guys remember that a little bit? Well, do you remember there was only one time that you only got one solution, okay? And that was when the underneath the square root part was 0. And what's happening is, let's say that we have like a little upward shaped parabola. You know, this would have 2 different solutions, right? But right here, at that vertex point, you only get one solution. And the one solution happens when b squared minus 4ac is 0. And so when that is 0, your x value is just negative b plus or minus 0, so that's just negative b over 2a. That's where this formula is coming from, is this idea of you only get one solution at the vertex. And when do you have that? It's when b squared minus 4ac is 0. So then you're adding or subtracting 0, and this is what the x value is. To find your y value, all you do, it looks really fancy, it's the f of, it's your function where you plug in negative b over 2a. Basically, you're going to get your x value, and then you substitute that back into your function, and that's where the y value comes from. Okay? So this is a shortcut to get you a vertex quickly. Just a reminder, the axis of symmetry is that vertical line that goes through the vertex right here. So it always has an x equals equation because it's a vertical line, and it equals that x coordinate from your vertex. So let's use the shortcut real quick for example 2. So we got the function f of x equals 2x squared minus 4x plus 1. So if I want to use the shortcut, right here, the x value is the opposite of b, so the opposite of negative 4 is positive 4, over 2a, so 2 times 2 would be 4. And then I can simplify that a bit. 4 divided by 4 is 1. So there's your x value. X is 1 for the vertex. For the y value, we're just going to plug 1 into our formula here, or into our equation that we have, and see what the y value is. So when x is 1, we'll have x squared, so 1 squared, which would be 1. 1 times 2 is 2. Minus, we'd have 4 times 1, which is 4, plus 1. 2 minus 4 is negative 2. Negative 2 plus 1 is negative 1. So we'd have a y value of negative 1. Putting those together, our vertex then would be 1, negative 1. Easy thing to add to that is that axis of symmetry, reminding you guys, axis of symmetry for our parabolas should be a vertical line, so it's always x equals a number. And it'll go through the vertex, so the x value of our vertex is 1, so x equals 1. That vertical line that goes through the x-axis at 1 is your axis of symmetry. Alright, next up, we're going to do some graphing. And we're going to do all sorts of stuff to this one, okay? So we're going to label all of our intercepts, we're going to graph our quadratic function, and when we're graphing, we're going to need our vertex, we're going to need our axis of symmetry, we're also going to look at intercepts. So I'm going to show you basically all of the things that you can find from this equation in standard form, and then we'll look at the graph, okay? Alright, so let's see, we talked about finding the vertex. So for the vertex, for the x value, we're going to do the opposite of b, so opposite of negative 6 is positive 6, over 2a, 2 times 1 is 2, 6 divided by 2 is 3. So there's our x-coordinate of the vertex. For the y-coordinate of the vertex, we're just going to substitute 3 in for x into our equation. So 3 squared is 9 minus 6 times 3 is 18, and we have a plus 5. So 9 minus 18 would be negative 9. Negative 9 plus 5 would be negative 4. So there's your vertex at 3, negative 4. Our axis of symmetry would be the vertical line going through that vertex. So x equals the x-coordinate, which is 3. And then it says, hey, why don't you label your intercepts too? You can actually find all of your intercepts from the equation pretty easily, okay? So just a reminder about intercepts, they happen when the other value is 0. So if you're trying to find your x-intercept happens when your y value is 0. So over to the side, I'm going to have 0 for my y value, for my f of x, equals x squared minus 6x plus 5. And then I'm going to solve for my x value. This one actually factors really, really nicely. So why not do that? This would be x minus 5 times x minus 1. So then we'll have x minus 5 equals 0 and x minus 1 equals 0. I'll add 5 to both sides and get x equals 5. I'll add 1 to both sides and get x equals 1. we have two different x-intercepts. One of them is at the point 5, 0. The other one is at the point 1, 0. See, the y-intercept is also pretty easy to find. The y-intercept happens when x is 0. So we'll have that f of x, that's our y value. And I'm going to substitute 0 in for x. So I'll have 0 squared minus 6 times 0 plus 5. I'm just putting in 0 for y, okay? So 0 squared, of course, is 0. 6 times 0 is 0. And then we'll add 5. So we've got 0 minus 0, which is 0. 0 plus 5, which is 5. And now we have a y-intercept at the point where x is 0 and y is 5. So you can see all of that information that I can find from my equation. Now that we have all of that information, let's go ahead and put that onto a graph. Okay. So let's see here. We've got a vertex of 3, negative 4, so I'm going to go ahead and plot that. We have an axis of symmetry, that's the line x equals 3. Here's my vertical line that goes through the x-axis at 3. I've got an x-intercept at 5, 0, and at 1, 0. Here's my x-intercepts, and you'll notice that they're both 2 away from the axis of symmetry, so they're nice and symmetrical with each other. Let's see, we've got a y-intercept at 0, 5. We could even use that axis of symmetry to make another point if you want to, because we have this point at 0, 5. It's 3 away from the line. If I go 3 away on the other side, we're going to have an identical line. So we've got a lot of points here. We can easily make a very pretty U shape for our parabola. Now it's your all's turn. You get to try one and show me how much you've learned.